This is Year 12 methods, and it's the normal distribution and introducing the standard normal distribution Z. If I have two independent variables, two normally distributed variables, x and y. X is normally distributed with a mean of 10 and a variance of 3, so it's got a mean of 10 and a variance of 3, whereas y has a mean of 5, but its variance is bigger at 4. It's very hard to compare these distributions. It's very hard to know whether x being less than 8, how that compares to y being greater than 8, because the distributions are centered at different numbers and they have different spreads or different variance. So what I do is I convert it to z, where z is normally distributed and it has a mean of 0 and a variance of 1. So z distributions have always got a mean of 0 and a variance of 1. And I can turn x into z by using the rule z equals x minus mu over the standard deviation. In x's case, that would be x minus 10 over 3. That gives you the z value. And in this particular case, z would equal y minus its mean divided by its standard deviation, which means z will equal y minus 5 divided by 4. That's how I use the rule to change something that has a mean and standard deviation different to z into a z-score. Okay, well, how might we use z, and how might I answer questions involving z? Remember, I know that z is normally distributed with a mean of 0 and a standard deviation of 1. So if I've been given questions like, what is the probability that z is less than or equal to -1? Well, I know that that will look like a normal distribution with a mean of 0. There's -1. I'm looking for that area. What is the probability that z is greater than or equal to 0? 0. That's going to be all of this. And because it's perfectly symmetrical, I know that's going to equal 0.5. And the modulus of z is less than 0.5. Well, if z is positive, therefore that's z less than 0.5. If z is negative, therefore that's minus z is less than 0.5, which means z is greater than -0.5. So this is the same as writing the probability that z is greater than -0.5 and less than 0.5. And I can use my calculator. So what would that look like? 0, 0.5 on the negative, 0.5 on the positive. That's that area in between there. Okay, so what would these look like on the calculator? Place the calculator in a spot where you can see it. Distribution, normal, CDF. For this one here, the lower is -infinity. The upper is -1. By default, the standard deviation and the mean is set for the z values of the standard normal. Press OK, and that tells me that probability equals 0.158655 or 0.1587 to 4 decimal places. The second one, distribution normal CDF, greater than 0, so the lower is 0, the upper is infinity, okay, and of course 0.5, which is what I predicted. And lastly, this one here, distribution normal CDF. No, I'll start there again. distribution, normal CDF. My lower is negative 0.5. My upper is 0.5. Okay, and that gives me a probability of equaling 0.38292, so that stays at 29. A second example of how to use Z is when I've been given X is normally distributed and I've been given the mean, but I don't know the standard deviation. But I do know the probability that X is less than 9 is 0.3. So if I was to graph X, it's going to have a mean of 10, but I don't know its standard deviation. But less than or equal to 9 is a probability of 0.3. Now I can't use my calculator to use the inverse normal because I don't know the standard deviation. So what I'm going to use instead is Z. Now the appropriate graph for Z is this, where that probability is 0.3. I'd like to use the calculator to find out what is that Z value. And then I'd like to use Z equals X minus mu over standard deviation to link the two together. So I'll use my calculator, and on my calculator I'll go inverse distribution, inverse normal CDF. This time it's a left tail, so I'll leave the tail setting as left. The probability is 0.3 and it's Z, so I'll leave the standard deviation and mean at 1 and 0. And that tells me that that Z value is negative 0.5244. So I'm now going to use the fact that Z equals X minus mu over standard deviation. The Z value is negative 0.5244 equals X, which is 9, minus the mean, which is 10, over the standard deviation. I now have an equation that only has one unknown, the standard deviation. So if we move that up over there and that down over there, the standard deviation equals negative 1 over negative 0.5244. The standard deviation equals, bring up the keyboard, bring up a fraction. On the top I've got negative 1, and on the bottom I've got that last answer, and execute 1.907. So that is the standard deviation for X. And the way that I did it is I linked X to Z, then I used the calculator in Z, and I used this equation going back to X. And the last example covered in class to do with Z, the weight of watermelons is normally distributed. If 10% of the watermelons weigh more than 4 kilograms, therefore the probability that W is greater than 4 equals 10%, 0.1, and 40% weigh less than 2 kilograms, probability that W is less than 2 is equal to 0.4, find the mean weight and its standard deviation. So I know that W is normally distributed, but I don't know the mean or the standard deviation. What would it look like? This is W, normally distributed. I don't know the mean, but I do know that less than 2 is 0.4, and greater than 4 is 0.1. So what I'd like to do is I'd like to use Z and find the appropriate values of Z that correspond to 0.4 on a left tail and 0.1 on a right tail, and find these two values of Z1 and Z2. So what does the calculator give me? interactive inverse distribution CDF. I want left tail, a probability of 0.4. Okay, and that tells me that Z equals negative 0.2533, and interactive inverse distribution normal CDF, I now want right tail, and the probability is 0.1, and that tells me that Z equals 1.28155. Okay, now with that information, I can generate two equations. I know that Z will equal W minus the mean over the standard deviation. Now, I might use Z equals W minus M over S. Using the first piece of information, I know that negative 0.2533 will equal W, which is 2 minus M over S, and that's equation number 1. And using this piece of information, 1.28155 equals W, which is 4 minus M over S, equation number 2. Now I'm going to solve that simultaneously. As you can see, I've loaded those into the simultaneous equation app on the ClassPad. When I press XE, it solves for M and it tells me that the mean is 2.33. kilograms, and the standard deviation equals 1.30, so 1.3 kilograms. So that's the mean and standard deviation of watermelons.